Hi, Mika des. Hello, everyone. I'm Mika, your company man of YouTubers in the clouds, which are always flying planes. We're not flying planes today. We are playing with sensitive, high value electronics. One sec. Playlist, play shuffled, play now. There we go. Not that song. That works. But I have here an oscilloscope. Don't shock yourself. Today we're probably going to be playing mostly with voltages below 10 volts, amperages of nearly non-existent. And excuse me if things are a little fucky because the camera is right here facing towards me. I have a light right up there. The camera for VTube Studio is over there. My microphone is over there. So it's a very cluttered space. If I go here, the camera can't even see me. Analog, this is not oh, so I'm gonna get into what we have here. So what we have here is a Tektronix 2245A. It's a little blurry, but it's a 100 millihertz oscilloscope. It is a CRT oscilloscope, but it is not an analog oscilloscope necessarily. It has some analog components. However, it has microprocessors in it. It is primarily a digital trying to display vector graphics using the XY mode. I believe it has an XY mode, but I was not able to figure any of that out. I've been reading the manual for this thing. Wouldn't that be megahertz? Didn't I say megahertz? 100 megahertz? If I said millihertz, then I apologize. I misspoke. But I scored this thing for about really $65 on eBay with $65 shipping, which, I mean, I understand it's an oscilloscope. It's a pretty big thing. It weighs about half as much as I would expect. Oh, actually, I see XY mode right here. Don't think the manual really explained that. This thing seems to be in pretty good condition. There's a bunch of dust in like the crevices of the controls. And I'll be honest, I fired the thing up to make sure that it worked, because like if it didn't even power on, I was gonna complain on eBay because the listing said powers on. So I was gonna hold it to that. So I have powered it on. I poked around in it a bit more than I probably should have, but I was too excited. But we'll do some poking and prodding and learning here. Like one thing I learned that I didn't realize is this thing has a cursor. Cursor. I haven't figured out how to use it yet. We're going to do that. Live. I have not connected any probes to it. This thing shipped to me from the guy who shipped it with covers on all of the BNC connectors. And I have... After shipping, it cost me as much as the scope itself costed, but I've got 200 megahertz oscilloscope probes. I opened these up to make sure I read the manual, figure out how I'm going to be able to calibrate them. What do oscilloscopes do, by the way? So an oscilloscope is a graph. You have time on the x-axis and voltage on the y-axis. And I might need to shift this over so you can see the whole thing. On the y-axis, you have voltage. So an oscilloscope is really useful for looking at what the voltage of a circuit is as it changes with time. Now, it's a little more complicated than that, because a lot of the time, if you were to just display a live view of the voltage from a circuit, it's just going to be a blur. You're not going to be able to see it, because most circuits are going to be running at kilohertz, thousands of hertz, which the human eye is not going to really see more than, even if you're a jet fighter pilot, you're not going to see more than 200 hertz And even at 200 hertz, you're not going to be able to make an accurate measurement. So this thing theoretically should be calibrated. It's got a calibration sticker on the back. It's half peeling off. I don't think anybody's poked around inside this thing, but it might still be calibrated. We'll actually kind of find that out tonight. Because what I have to calibrate this, or at least kind of check the calibration of this, is an old excuse me while I just throw things on the floor. An old Arduino, and it's actually a Sane Smart knockoff Arduino. So I have an Arduino Uno. This is the one that I've got in college, the one that I bought in college, and making this case for it was a project that we actually had to do in one of my engineering classes. So it's CNC machined out. It was made out of a bunch of flat plastic plates. Use the built-in square wave. I mean, we'll use the built-in square wave, but I mean, it's fun to have an outside reference to check, because what we can do, you've got the blue one. Yeah, blue one should be actual Arduino, but we can use the Arduino and this multimeter I have. The multimeter, we can measure what output the Arduino is giving us, and we can put a PWM output from the Arduino and make sure that the voltage is right. We can also kind of roughly check the timing, but not really. And yeah, there's a 1 kilohertz half volt signal generator built into the oscilloscope that's required to calibrate probes anyway. So that is going to be useful, but there's always the possibility that this isn't accurate. So it's fun to have something to correlate it. We'll also, you know, it's fun to do a little bit of Arduino programming. I had to spend a lot of I am late to stream because I spent like 30 minutes trying to dig out my Arduino. I have 2 Arduino kits. I can't find the other one. I found the one from college though, because it's been sitting in this corner over by my modem for the past like 5 years. So, I meant to mention it, but there's a more this displays current or voltage versus time. However, it is more complicated than that, because most signals are going to be in hundreds or more hertz. Digital stuff is going to be in megahertz. Like this Arduino, if I'm not mistaken, it runs at about 3 megahertz. Got an Atmega 328P Atmega 328P processor in it. I have done a lot with this Arduino. I have gone so far as port manipulation, manually operating the timers, because a 3 megahertz processor is pretty strong, but when you start using the built-in Arduino delay and stuff, it's just not good enough. Built-in Arduino interrupts are pretty darn good. However, when you get to the point of like stupid shit that I had to do in college, like you need to manually operate a speaker, that's where the Arduino's processor starts to struggle. It can't do that fast enough with built-in routines and libraries, so you have to kind of just do it manually, so that way you can reduce the number of lines that are going on. Because you're doing something specific. You're just turning a thing on and off at a specific hertz, whereas like the interrupt libraries built into the Arduino and the interrupt commands built into the Arduino, those have to work for like all sorts of different things, so it's a bit more code that it's executing. So, but because frequencies are so fast of signals we want to do, like this thing is rated for 100 megahertz. See that? 100 megahertz. We can't see a 100 megahertz signal. It's just going to be a blur if it plays it live. So what we have, and I'm going to have to shimmy this over. Excuse me while I move this Arduino. Ah! There goes my VTube Studio camera getting caught by a wire. I have both of the cameras just set up on top of this oscilloscope because it's taking up all my desk space. But we also have this trigger setup. So there's a lot of options we have for triggers, and what it'll do is I don't know if this one can do both. We'll find it out. But on the oscilloscopes I used in college, which were fairly newer than this, I think they were probably digital. What you pretty much have to do with an oscilloscope is you have to trigger on a signal. So you have to say, hey, when the signal gets above this voltage, that's when I want you to capture it. So you'll have a signal that's going, let's say 60 hertz, but it's actually going to vary. You know, if you just try to take a snapshot every 60 hertz, you might be at 59, you might be 61 hertz, and you might be off on this, and then you can't really measure anything, and it's just going to be a blur. Especially at higher frequencies, it's just going to be a blur. So we have a trigger that that grabs the signal on the rising edge at the level we specify, and potentially on a falling edge if this has that. I don't entirely know because I haven't poked around with it that much. So we'll find out. Bit banging PWM, yep. Should be timers that generate them. On the Atmega 328P, you have three timers. I've since forgotten a lot of the specifics of it, but I know two of them are larger and one of them is smaller. And so the way you do the triggers is the timer's counting up one every clock cycle on the Atmega 328P. So what you do is you say, hey, after X number of seconds, I want this thing to trigger. Then what you do is you have it go through. It compares like OCCR1A to a bit number so that and you put it in in like bits. So that way it doesn't have to try to convert from decimal, which is going to take you clock cycles, and you have it do a comparison of that. And once the timer gets to the height of what you set, because it's rising every clock cycle, once it gets there, you have an interrupt, which is going to interrupt everything, and it's going to set a flag from 0 to 1. And then your loop is running in the background of all of this. And when the loop sees that, it's going to trigger. So you have to make your loop fast enough to grab it, and you have to not load down all the timers and everything. So it's like if you try to interrupt and you make the interrupt do like 3,000 commands, it's going to fuck all the timing up. Don't ask me how I know. I've tried that. When you're trying to debug Arduino code by using interrupts and shoving the serial port in, it doesn't work. It doesn't work at all. That's where an oscilloscope could help you. All right, let's turn this thing on. As I said, spoiler alert, I already know that it turns on. It takes a little bit to turn on because it runs a self-test. Also, these are all LEDs, I believe. So you're going to see them flicker. And you're going to see we've got uncal warnings up here. We also have a vert warning over here. We have a vert warning. I don't know if that actually is important or not because the scope passes all of its internal self-tests, it seems. That anything that it runs on startup, it seems to pass. But you see that we've got, right off the bat, we got two blank traces, channel 1, channel 2, because that's what we have selected. If we turn off channel 2 goes away. We can move them up and down. I don't know if you guys can see this, but it appears that they're slightly askew. So if you look at, you probably can't see this, but I've got the right side centered on the center line, and it's slightly off. I wish I had brought a flashlight. I'm going to need a flashlight for this because there's a trace rotation thing. That's the first thing I'd like to fix. I'll be right back real quick. I think it's a flathead. I don't know. I can't really tell. But we're going to try to calibrate this, try to adjust the rotation. It's only off by a little bit, but it's enough to frustrate me. That's not going to reach. So I need a really tiny screwdriver, a really long neck, and unless I just got really lucky. No, I did not. I have no idea where my really long, tiny screwdrivers are. Bye, spaceman. I'm gonna cover the camera for a second. Oh yeah, that's a flathead. I have this screwdriver, which no, that's the trace rotation is really far back. I can try to search my desk real quick. If I have any small screwdrivers, they are buried under a mountain of garbage that I have on my desk. Because I am a good human being. Man, I have like a whole gunsmithing set of bits, screwdriver bits, and none of them are gonna work for this. Wow, it's got a couple like really good pin punches, but no. Well, that sucks. Please don't. Please don't dox yourself again. I'll be fine. I'm sure it's okay, spaceman. Right? Believe in the me who believes in me. What junk does Mika have on his floor? A pair of AR mags. What do you mean again? What do I mean about what? What am I trying to do? There's the trace is slightly off from the line. I don't think you guys have enough resolution to really see it, but it's right on the right side. On the left side, it's about a beam width down. So I'd like to hit the trace rotation. However, it's a flathead screwdriver position that has to be really far back. And I have misplaced all of my tiny screwdrivers that can manage that. I have just knocked a box of 5.7 ammo onto the floor. I'll give you guys the play-by-play. Found my old CPU heatsink. Oh, hey, that's where this cable went. All right, I can't find that screwdriver. It would be there if it was. It is not. So oh well. It's enough. It's a noticeable enough difference to fail to read. Yeah, that's why I'd like to fix it. Man, I can't find my screwdrivers at all. This is gonna bug me. Let me check one of my other workbenches. Yes, I have multiple workbenches. Okay, it's not a screwdriver, but I have this like cleaning tool for firearms that has basically a flathead end. just gotta. That was too much. That looks pretty good. Hey, we got it. All right, first obstacle cleared. Other obstacle, uncal warning. From what the manual says, I just have to do click, 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 and we're good. It's calibrated again. I don't really know what that does, but that's what we've done, and it does that. Now, let's turn off channel 2. If I hit both these buttons at the same time, we have this. So I can run a diagnose. Running until fail. Triggers. Uh-oh. Oh. Shift registers, DAC, triggers. Oh, is it just running fine? How do I exit? How do I stop it? Reboot. Uh-oh. What did that just say? Number something. Uh-huh. All right, let's try a self-cal measurement. Actually, that won't work. Because we don't have scope probes plugged in, and we got to calibrate the scope probes first. Let's get a scope probe connected. This is our scope probe. On this end, it has a little hole in it for calibration, because you have to match probes to your scope. Tolerance is too much in manufacturing, so you have to have a little bit of adjustment capability. There we go. Connect channel A to what should be a 1 kilohertz. And then ground. Ground didn't do anything. Probably doesn't help that we're at 5 volts per division. Oh hey, did it just trigger and catch this? Let's. How was it I did time again? That's channel A, that's channel B. There we go. So let's get it nice and big on our screen. And what we can see, you're on eBay looking for oscopes. I got one of the best deals that I could have gotten from this thing. So what we're looking for is it's a square wave, but at the end it's got a little bit of a wiggly. And we need to stick the tool in and adjust it until the wiggly goes away, I think. I have no idea if this is working or not. That's making it worse, I think. Um, um, is it working? Oh, joy. Um, I had the probe at 1x, not 10x, which is going to make it have all sorts of wonky problems. Okay, there's our beam. There we go. Now we gotta unfuck whatever we just fucked up. Okay, so that's probably about as nice as that one's gonna get. Crusty as hell. I was lucky that I was like, man, I've wanted an oscilloscope for a while. Let's look on eBay. $80 turns on. Buys. Like, no joke, I bought it without doing any research. I went, oh, Tektronix, I know them. I used their newer scopes in college. And that was it. Now I could have done my research and found out that this was a fantastic buy. Alas, I did not. And I still talked the guy down like $15. Channel 2. Channel 2 is a little fuzzy here. But it looks like it's in a good state. Oh, wait. Oh, having channel 1 connected was causing us problems with channel 2. Channel 2 is still kind of fuzzy. Let's try taking it off and back on again. I wonder if I need to set up a trigger for channel 2. Oh, wait. That's what was wrong. I was using add, not I wasn't actually on channel 2. That would explain a lot. Get the probe adjusted. I've never actually had to adjust scope probes before. I didn't know that you even needed to adjust scope probes. Because every scope I've used was already set up. Chinese digital scopes are dirt cheap. Not cheaper than this baby at a although I've paid like 190 total between the scope shipping and everything else really. Scope shipping and probes. That's what I've paid. Chat, would you like a salted caramel chocolate square? Oh. All right. 12 cal measurement. Run. Hi, Quentin. Dogs can't eat chocolate. Shh, shh. Don't tell anyone. I can eat the chocolate as long as you don't tell anyone that I'm eating the chocolate. It looks like the self-cal ran fine. And here we see our two square waves.
Warning. Spaceman 634 gifted a tier 1 subscription to Quenterich.
You don't think the dog is smart enough to realize it's bad for him? No, I'm just so smart I realize it doesn't matter and I can eat whatever I want, okay? Like onions. Alright, well, that's what we've done with this thing. I like how on stream it's just blinking constantly. Turn off channel 2. Let's figure out how the heck cursors work. Oh, okay. So that is actually really neat, although pretty low tech. So some of the scopes that I've used, they've had cursors where it's just like you turn on the cursor and then suddenly it grabs the min and the max voltage. The way that this works is you've got clear measurement. You turn on the cursor and you get two dotted lines here that you guys can see that are flashing here on screen because this is a CRT. It's all just being drawn. And actually, to further show that, I can turn on both channels. And then what I can do, although you're getting a lot more messy of a signal here. I just have to slow down the time. And then you can see the CRT drawing the beam across the screen. How goddamn cool is that? It can go so slow. I can adjust the intensity for you guys. That looks good. The illumination, the scale illumination doesn't seem to do anything. I don't know if that's just worn out from use or what. Not that that really matters for me. Then we have focus, which is important. But honestly, this scope looks really good. It's a little blurry, but you expect that from a CRT, really. Get the camera attachment to capture that slow signal. And we can go... Now I have to turn the intensity up. So it could go down to 0.1 milliseconds, 50 nanoseconds, and then lowest is, or sorry, that was micro, 20 nanoseconds. And what's really neat is that it's got the beam find, which is suddenly not working. Actually, it's probably for if we're way off the volts per division, I think. All right, what else? Um, um, uh, Let me toss these back onto here so that they don't get lost. And now VTube Studio is going to throw a hissy fit because I'm going to be over here. It is time for coding. Window capture. Oh, Spaceman, you want me to... There you go. Have an Arduino IDE window that hopefully will not dox me. And then I need my box of Arduino bits because I'm gonna need a breadboard for this. I haven't seen that interface in forever. Oh yeah, I've got this tiny little breadboard. And I really just need some wires, I think. I had to unplug stuff that I normally don't unplug from my computer, specifically for this, to have the USB ports so I could plug in an Arduino. I hope you guys are appreciative of me. And if I remember correctly, Arduino needs A0, A1, A2, A3, or A4, A5 maybe for PWM output, or maybe the Atmaga 328P was a little wonky in what it needed for PWM output. I think it needed different pins, or maybe that was for port manipulation and trigger captures, I think. I had a whole document that was really useful for this at some point, and I lost it. Void setup. Nope. Analog right. Into 7. What is the context for analog right, though? Arduino, analog right. Link's dead. Did you point the camera at the thing? I did point the camera at the thing. I'm pointing the camera at the thing. Hey, where'd the thingies go? There we go. Here they are. Where did it go? Where did it leave? And beam find is not gonna help me. Channel 2, you wanna play as well? Why did doing that make the channels both disappear? Here you go. The two calibration square waves. Ooh, fancy lines. And now we're gonna do a PWM output, which is gonna look almost identical because although PWM is 500 hertz. Arduino, analog right. Analog right, God, I have not Arduino'd in forever. Pin mode, can we just do 3 output analog right 3 comma 127. You haven't oscilloscope since this morning. I'm gonna oscilloscope. Let me put one wire into the ground, one wire into pin number 3. Is this gonna work? No, yeah, it should work with should work fine, I hope. No board selected, right. Tools. Board. Board. Arduino Uno. No board. Okay, fine. I will select a board. It's an Arduino Uno of some sort. How do I get rid of this board manager thing now? There we go. Stop spraying me with the hose. Why do you need the hose? Uploading to the Arduino. Let's hide channel 2. Hey, look, you're getting something fuzzy because I haven't connected the ground yet. There you go. Wow, is this just set to auto trigger? This thing is like almost boringly easy to use. And we get 1, 2, 3, 4, 5, just shy of 5 volts. That's about what I would expect from an Arduino. Oh, sorry. There. You guys completely missed it. Let me do this all over again. So we had this square wave detected. And auto trigger. You want to work with me? I did it before. There we go. Now it's got it. It needed a little bit of thinking. So then I pulled this off. I connected to the Arduino pin, which gives you expected results because floating ground on an oscilloscope. And then I connected the Arduino's ground for the reference. And now we got it. Now we'll measure from down here. So we'll put the bottom of the trace at this line, and we get one. We're at 0.1 volts per division. So 1, 2, 3, 4, 5. Hey, wait a second. That's 0.5. Is my math not mathing? Am I supposed to be in 10 times mag? No, we're not. How, huh? No, with that's kind of boring, isn't that? Isn't it? Isn't it? Now we have a less boring thing we can do. I don't know how much you guys can see. We have the steam engine. So what I can do is I can pull off. That's the wrong wire I just pulled off. I can pull off the wires from the steam engine. And you thought you'd escape this stream without the steam engine coming up, huh? Huh? I need the red wire and the yellow wire. I gotta put the steam engine down. And we have to fire up the steam engine. How goes the oscilloscope? We've got a PWM output right here from an Arduino. We could we can do a little bit more coding. Pin mode 4, output analog write 4, 33. I don't know. We'll just do that and we'll upload that to the board. I'll grab another wire. Get into port 4. We'll grab the channel B probe. Connect it to the wire. Connect the ground to the ground wire because grounding an oscilloscope is really important. Or grounding your signal is really important for it to see anything. And we can turn on channel 2. Channel 2 is a blur. It's this one that I'm moving up and down. The scope is really cool. I like the combination of digital smarts with the CRT. It's very like 2004, although this is a 1986 era oscope. Well, so then we're at 0.2 volts per division for the for channel A. So channel B, we got to go up more. Huh? 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 Why are we not finding it? Should be working. Uh, 127 upload. There's channel A. Channel B should match it. I don't know what's going on. Oh, although 3 might be, or 4 might not be a PWM output. That's part of the trouble with the Arduino Uno. All right, let's try 2. $11? Let's try 11. There we go. Yeah, Arduino is fucky. The Arduino Uno is a little fucky with which outputs are PWMable. All right, so now here you can see we've got wave A and we've got PWM wave B. Actually, let's put A at the top, B at the bottom. So the top is a 50% PWM. The bottom is 33 out of 255. Much intense, very wow. But yeah, it's neat that you can see that. And apparently there's a way that you can set up an Arduino to output a sine wave. That is a fuckload of effort that I'm not putting in because I mean, it's a bunch of code that I can just copy, but I don't feel like copying so much code on stream. All right, next up, we can figure out what the heck the output of our steam engine looks like. Turn off channel 2. This might be a floating ground kind of scenario, but we'll try it and see what happens. It's not going to be more than like 5 volts, almost certainly. I still have the output in DC. I hope so. What the heck is it? What is it seeing? The fuck is it seeing here? Oh wait, I see. There's a button for rising versus falling action actually here. Interesting. Oh boy, what the heck did I just find? Excuse me, sir, the alternator's not doing anything. It should output a straight line. You would think so, except Spaceman, I can see the LED blinking. Now, I still have the glass of the ionized water from before when we were testing the steam engine a couple days ago. We're gonna We're gonna use that. We're gonna use that to steam engine some more. All right, steam engine has its WADA. I need to put the safety valve. You gotta reset like the digitals do. Safety valve works. It is occurring to me that I might need to do a little bit more than just plug things in on this. So we're gonna do a little bit of breadboard work. Do I have a red wire? Wow, Mika has 0 red wires. Okay, I've got an orange wire and some other things, and like I have like 300 ultrasonic sensors because I got a pack of like 10 for $17, and I needed that for my class desperately to bring down the price of my robot. We also have a bunch of like switches soldered to shit and things. Okay. Yellow is gonna be red. Or no, yellow is gonna be yellow. And green is black is gonna be red, or maybe blue's red. I don't know. Because I don't want to break the circuit to take a measurement. We don't really need to. So I just want to route it somewhere where I can actually measure it. This whole thing's closed off. Let me close the regulator fully so we don't get water where it's not supposed to go. Oh, I'm blocking my camera with the light. Let me just take this entire boiler and overturn it. Okay, so yellow to yellow. I'm reattaching the... Are these Wagos not gonna grab? Okay, there we go. Yellow to yellow. The black goes to the reds. The red Wago. Hey, Spaceman, when are we gonna watch Full Metal Panic? It has a submarine in it. You might like it. You're scoping your O's. I'm gonna oh. Welcome in, Air Show. We're about to we're plugging in the steam engine to things. See what happens. It's gonna make me want my soldering iron to do certain things. Yellow to yellow. I gotta plug the red. How's it working? The oscilloscope is working fantastic. It is outputting about what I would expect. So let me pop this back over. Blue into 3, green into brown, because ground is green in the US. Connect the scope, you see it got fuzzy. Connect the ground to the Arduino. It's not gonna grab it, is it? There we go. Got it. So what we're looking at is a PWM 50% output from an Arduino. Oh, and I bumped the camera. 50% PWM output from an Arduino. So we can use the cursor for volts. Put it at our baseline. Bring it down. And we're seeing 0.486 volts, which is kind of what I would expect from this Arduino that I have. I know pretty well from the many years I've spent using it that it does not output 5 volts exactly. If you have an Arduino putting out like 5 volts, you need like a specific resistor to run to LEDs, and then so that the LEDs don't explode. And I can just cram an LED from 5 volt to ground on this Arduino, and it survives. Which unfortunately, one girl in my class got very angry at me because I blew up one of her LEDs by telling her that she could, because on my Arduino it works. Nope. Put in a 220 ohm resistor for your LED circuits, boys and girls. It's important. But we're hooking up the thingy majigger, the steam engine right now. So in the meantime, have this calibration square wave that tells me apparently we didn't calibrate this thing all that great, and I've left my calibration tool under here. There we go. Judging by the camera, he's about to dox himself again. All right, this is a familiar sight. We've got our burners. What could go wrong? Electronics and fire. I'm sure this is perfectly fine. I'm working with like no desk space here, so bear with me. I think we said this thing took 30 milliliters of alcohol last time. Might have been 20. Oh god, it burns my eyes already. Ah yes, let me just have a rum and coke and then play with sensitive electronics and fire. What could go wrong? Chat, what could go wrong? Yeah, it was 20 milliliters we needed. We gotta fix the burners. They're not sitting nice. All right, got the burners in. Where did that cheap Bic lighter go? I'm reaching around. I got it. Okay, they're lit. They're just really hard to see because alcohol burns super clear. Steam engine is starting to go. One lead is connected, and here's the ground. I'm going to put it on 0.2 because we expect the signal to be somewhere around 0 to 5-ish volts. Boy, I sure did enjoy watching Mika VT before the tragic alcohol Sons of Electronics fire incident of 2025. If you'd like, Spaceman, I could add some IMR 4350 to that whole accident. I do still have fire extinguisher right on hand. It's right under this desk. So if anything happens, that fine. I would like me to be careful. I am. How explain how I'm not careful. Explain exactly in writing how OSHA would be upset at me. Other than me losing my glove I was using last time for this whole thing. At least I have the right-handed glove. No high-vis vest. I don't need a high-vis vest. We're not playing in traffic. Playing in traffic is next week. Come on, guys. Anyone want another salted caramel chocolate square? Oh. Having goggles, not using them? Fine. Safety third. Oh, you can see, just for me hand moving this, it's going. Not ready to chooch yet. All right, let me get other cool thing I have to show off. Now, let me remind you, this oscilloscope is like 2 Mika hands in width. So this next device is pretty sizable. This is a tachometer, a vibration tachometer, and it's vibrating like crazy because I just moved it. But it is a really, really cool device because the way it works is it's got a whole bunch of little reeds in there that I doubt you can see. But it has a whole bunch of little reeds. And the way it works is each one is a reed with a weight on the end of it. And more or less solder is added to get it to vibrate at the right natural frequency, so the right hertz to match an RPM. And this specific one, it looks like it was designed to be mounted to something. Sadly, it's got a riveted mount point for a nameplate and a second one for another nameplate and something else. And those are missing. But this is a really cool piece of old technology because it was funny because I actually showed my boss this. I'm like, hey, here's this thing. And he had no idea these existed. I had no idea these existed until until like a couple years ago when I saw a video from AVE on them, and I don't think AVE realized the potential for this thing. But my boss almost immediately recognized it, same as I did when I first saw the video. Because this is reading vibrations off of a machine's casing and assuming that that matches the RPM, um, it's really just a handheld vibration meter. So you could stick this up against something and you can measure the natural frequency that it's putting out from its motion. And you get a visual with this one, especially with how many different how much range it has. It gives you a lot of information, and you might see that there's certain ones that are moving more, like this one, and then this one, and then this one's moving a little bit, and that's likely due to these all having a common like denominator natural frequency. So you can stick this to a machine and you can get data on what the first mode and like what vibrational modes there are in it, something that you would really otherwise need a complicated piece of equipment like this for, but more specialized. And my boiler is starting to spit out stuff. So we might get some action soon. I don't know how well this is going to capture it. But if it doesn't capture anything, it'll just give me a live display, I think. And I think I can tell it to just... Boiler, stop spitting water out and make useful things. Oh, this is great. I'm spitting hot water from my boiler right onto an open electronic circuit. All right, you can't see it terribly well. There we go. Oh, that's really cool. That's really cool. You can see it adjusting, although I can't really get it in a good spot. Okay, that gets us fast enough that we can make it work. You get the cursor out here. So it's not really putting out all that much voltage. Oh, wait. I'm dumb. I didn't have the circuit turned on. Here we go. Although we can't get it in enough. We can try pulling this off and grounding it. There we go. That gets a little better signal. But, oh, it just fell off. All right, so I'm just grounding it. And this is exactly what I was expecting. There we go. So we have a sine wave. It's not triggering. Which I guess is fine, because it's giving us a live view of the power that the steam engine is generating. Although, I think the steam engine is blowing its whistle on its own. Which is an interesting issue. But okay. But isn't this cool? This is what I expected, because it's not a constant RPM output. It's accelerating while the piston's driving it, and then it has a dead zone, and then it's decelerating. And if I turn this down, you'll see that the period... Uh-oh. Why is it displaying a sine wave when nothing is happening? I might be completely wrong and off base, and I might have missed something. We should be expecting like 5 volts per division, or 5 volts. Hmm. Yeah, because this happens whether I turn it on or off. Or no, wait, whether I turn it on or off shouldn't matter. Was that just the noisy 60 hertz from everything in my room? Maybe. What's 1 over 60? That's 60 hertz. There you go. That might be just the noisy 60 hertz from everything in my room. Okay, fine. We can have this. That's not noise, though. That's a signal. It was matching 60 hertz pretty well, let's be honest. And here, this is working if I turn down the speed. So this is our signal, kind of. Although this doesn't really have like a ground either. It's just floating, which makes the oscilloscope measurement a little harder to do. Yeah, I've grounded one end, but the problem is the thing really isn't conducive to being grounded. Stop trying to zoom in so tight. I refuse. This should be the most live view I can give you. Although our boiler is quickly running out of steam here. If we put 60 hertz up here, actually this is just 60 hertz noise. Hee hee, oops. Sorry guys, I only know DC circuits now, whatever the heck this alternator's putting out on this thing. But look at that, we can find the noisy 60 hertz signal from our room. Isn't that cool? We don't even have to plug in to our we don't even have to plug into the wall to measure this. See that? 60 hertz, almost exactly. An alternator. I don't know if it's generating an alternating current or it's completely stopped right now. If I hook it up, it goes down. I don't know if it's outputting an alternating current or if it's rectifying the current on its own. Because as soon as it stopped, this went back kind of towards the middle of its position switch. So methinks that the generator in the steam engine has some electronics in it. It probably has an H bridge in it to generate a DC output. How would it self-rectify? An H bridge of diodes inside of it. Because it's not like, I know it looks like it's a single unit, but it's actually like a hobbyist motor bolted in. Feels wrong. I don't know, seems right to me. I mean, I could unbolt the thing and figure it out. Let's find out. 1, 2, 3, crunch. Mika pulls apart a steam engine live on stream while it's under pressure. Okay, it's not under pressure. I'm just put a load on it so it's not picking up 60 hertz. But where would I get a resistor from? Oh, right. Where the heck did I set? So I gotta unplug this, shove this here. And now it's just grounded to open air. plug this in. And then is it a red? And also see by just probing the connector on the LED. You're watching an engineer make things difficult syndrome in real time. We have a brown, red, black resistor. I don't know what that means. I don't remember what that means at this point. Hey, look, the load made it worse. Why do you, Spaceman, why can't I just, pull it off and take it apart and see how it works? It's only an extremely hot piece of equipment. Use a voltmeter to get the same reading? No, I don't wanna. Just probe the LED, but Spaceman, the boiler's so hot. This boiler is full of hot, almost boiling water, guys. And you're gonna make me turn this thing upside down? Oh, secret somewhere inside you. We shall prevail before my body dries. I gotta plug everything back in. Yeah. But where is the fun in using a normal voltmeter when I could not? You had surprised me then, saying a word. I gotta find the truth in this fight, 'cause I'm alone, you're the only one who can help me now, we'll be as one. Plugging the blue wire to the blue Wago. Wires have become giant RF antennas that aren't connected to actual signals. I believe that as well. And move my feet in the dark. Don't wanna be. Feel the heat, my blood. Remember what Okay, hear me out, but what if I got a power drill to spin this thing for testing purposes? All right, so I'm doing this manually right now, and you can see what me trying to do it is doing. Now that we've got a probe into the LED versus if I took the button off, put the button back on. Katara Kalen, thank you for the raid.
Katara_Kalen just raided the channel.
We are goofing around with an oscilloscope hooked to a steam engine with a little DC generator? Yeah, DC generator. So it's just gonna pull the signal down if we. Or I mean, that I don't know. That's kind of what we want. It's fine. It's fine. This is fine. Let me try to prep the generator for the steam engine for a second run. I think it's really hot. It's almost like there's a fire in it or something. The dog is engineering but poorly. That's because I don't get paid enough to engineer on stream. All right, here's our very, very hot safety valve. Neat. Still works. I gotta pull the safety valve off to fill it. What made me want to get an oscilloscope? I've wanted an oscilloscope for a long time because they're neat. All right, excuse me while I try to fill the engine next to my oscilloscope. I kind of have a list of things that I want in my head, and if I can get them at a reasonable price, I just kind of buy them without thinking. And this one was like $60, $65, $70, $130 after shipping. Took out the safety. I pulled the safety valve out, which makes it an open hole. Calm down. Calm your calming, spaceman. It is perfectly acceptable for me to do that. All right, now I need more alcohol. For the boiler, I mean. I also need some more alcohol, but for the boiler. And myself. 20 liters of pure grain alcohol with poison added to it. I'm gonna have to take my glove off to actually be able to light the lighter for this. I'm pouring the alcohol into the little burner. $20 milliliters fits perfectly in there. Add the burners back in. I gotta carefully set them up. God damn it. I don't have the desk space to deal with this shit. It's almost like this oscilloscope takes up most of my desk space. Alright. We'll light them on fire where I can see. Alright, they're both lit. Alright, boiler is set up, ready to go again. We need to get going. All right, thank you for the raid. Also, welcome in, raiders. I'm Meek, your company manager, teacher, head in the clouds, always flying planes. We're not flying planes today. We are doing science. I'm on the science team. Let me use this towel to prevent water from going on my brand new oscilloscope. So what we're looking at right now is we have just an AC voltage thing coming in. So it's just a noise signal. And when we start the engine, you'll get a little bit of a dip. It's likely not going to be capturable, which is going to be nice because it's just going to display kind of a signal. Oh, more snacks. And now we wait for the boiler. So how's everyone's week been? My week kind of sucked. My boss was like, "Hey, Mika, you're not doing anything important, right?" Not really. All right, drive across town and go help other location put up pallet racks. And that's how I spent Monday, Tuesday, and Wednesday. Putting up pallet racks. Getting paid like way too much money to put up pallet racks. Wednesday it sucked because like, you know, yeah, my boss is telling me to do something stupid. I'm still gonna put in a decent effort and I'm gonna try to get it done. Especially because I understand big picture that he doesn't really want to do this. It was supposed to be other groups' responsibility to get it taken care of, and they just didn't, and now it's our problem. But Wednesday he was like, "Oh yeah, I gotta go over to other location and I gotta like go to a meeting and do actual engineering work. Can you guys set up the rest of the stuff?" And then the second he left, two guys bailed on me, so it was me and one other guy, and the other guy was busy running a forklift moving stuff around. So I'm like, yes, I have to climb up in the pallet racks with a harness and try to like solo lift these heavy beams and put them up. Which they're 9-foot beams, so they're not too bad. And I was like, yeah, 9-foot beams, it's not too bad. I could do that. But I took an ibuprofen on Wednesday because my muscles were all in pain peco. And then I went to like try to lift I lifted up one of the 9-foot beams and I got it to like my waist and it's like, okay, this is fine. And then I tried to get it like past my chest and my muscles were just like, nope, 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 nope. It wasn't like pain and the stress you get. It was just, oh, we refuse to move. I'm like, oh god. And so I didn't put up like any beams. Luckily, my boss didn't complain to me about it because like I put up one beam and that was all I could manage on my own. And he didn't complain to me. Which I expected he would have been like, "Hey, what the heck gives?" And I would have told him like, "Oh, well, you know, dude X and dude Y bailed on me, so what am I supposed to do?" All right, steam engine is ready to start rolling again. I mean, it's not exactly rolling; it's kind of just sitting here, but you get what I mean, right? Closing the cylinder cocks. It started on its own. Hot damn. So you can see there's the AC line voltage. I put that at the baseline. So we're getting a DC signal more or less, it looks like. So yeah, that's what we're getting. We're getting a rectified signal, which is a little unfortunate because I was hoping to not really get a rectified signal. But you can see that it's not a perfectly rectified signal. If I turn this off and pull it back, you get the AC noise. But you get the little messy bit because this is a sine wave that's been tried to be pulled down. AC couple the signal. That didn't work. I guess that technically does work. I mean, that puts it towards the center. Yeah, that makes sense. I don't think the cursor is working. There it is. Okay. Well, we're only measuring millivolts out of this. Although it's referenced to something else, so yeah. So if we un-AC couple it, turn off this, we have the baseline, and I zoom out again. There's our baseline. If we try to center the baseline as best as we can, and I'm gonna have to zoom out a bit more, I think. We're only really reading, although we're not producing enough to light up the LED. There we go. Ooh, that's cool. Turn it off. There's the AC line noise. Turn it back on. And that's our 0.2 volts this is outputting. Because yeah, it's not lighting up the LED at all. So that makes sense. We're not putting out. And you can see it slow down with time. I assume we can reference to the noise middle. Or we might be offset, but it's kind of neat. And you can see the sine wave of this as we zoom out, and its motion becomes slower and slower. This is going jump, 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 jump. It's doing about 1 rotation per second now, and it's slowing down. All right, so now what? That's all I had. That's all I had planned. Anyone else have thoughts on goofy things we can do pretty quickly? Now beat Doom on it. I mean, we've got the XY mode, which is just showing you goofy things. So we could do that. But Spaceman, you got to get me all the stuff I need to display Doom on this. You can see it chooching very, very slowly. It's still actually chooching. It's going and stopping and going and stopping. An RWR display. That sounds like too much effort. Maybe we can break into that alternator and clip right onto its leads at some point. See what that gives us. I'm surprised this thing's still chooching along. Oh, it stopped. Do I have a Z input? I do have a Z input. It's on the very back. Although what concerns me is in XY mode it says it's clear that this is X. This doesn't say Y. This doesn't say Y. Channel 4 doesn't say Y. Although I know that Z is in the back. It's clearly labeled as Z. Choo-choo. Whistle. Oh my god, that whistle is so loud for such a small steam engine. All right. I've got nothing else to add to this. So I think I'm going to prepare to raid. I will leave you all with this beautiful oscilloscope image and a glove thrown on top of it as I clear myself enough space to reach my mouse. We can do this. I think someone showed me a video of Doom on specifically the Tektronix 2245. It's if it's got XY mode and then the Z, it's not really that hard, right? Composite video to XYZ circuit. Yeah, that's the hardest part. Who is online that we can possibly raid Shadow Legends? I'm also glad to see that our internet held up. I contacted my ISP this past week because my internet totally shot the bed, and they went, "Oh wow, you've got some really awful signal loss." And I told them, "Hey, this has been going on for a while," and they're like, "Oh, okay, well, we'll send a technician out and we'll get it fixed." And they did. They've called me 3 times. They called me every day since I did this. Since I put in since I called them, they called me every day asking if things are fixed. But Wednesday and Thursday I was out of the house, so I had never gotten a chance to do anything with it. so I didn't know if it was actually fixed, and now it seems like we're perfectly fine. Knock on wood, knock on wood. Are there any cool science VTubers on? Is there anyone else in science and technology? Oh wait, the VTuber who does stuff, science and technology stuff is on. Ooh slab. Oh, First Robotics is doing stuff. That's interesting. Yeah, it'd be Las Vegas regional. It seems a little late for a regional, huh? Interesting. But let's raid Ooze Lab. I've seen some of this guy's clips. He's pretty funny. We're gonna raid into a massive channel, but worth. Make sure you all give him a nice raid. Either the one with my emotes or the one without my emotes, depending on what you have. Please look forward to potentially doing more shenanigans on this oscope. If Spaceman can convince me to do Doom on this thing, as in like it doesn't cost me more than $30 to set up Doom on this, I will play Doom on this oscilloscope, and it will be awful. All right. I will be back probably tomorrow. I don't know. We'll see. Bye-bye.